Chances are, we've all heard about it more than once in our lifetimes, and even have some thoughts of our own on the subject. But for space agencies around the world, futurists, and private aerospace companies, the idea of colonizing the moon is not a question of if, but when and how. For some, establishing a permanent human presence on the moon is a matter of destiny, while for others, it's a matter of survival. Not surprisingly, plans for establishing a human settlement predate both the moon landing and the space race. In the past few decades, many of these plans have been dusted off and updated, thanks to plans for a renewed era of lunar exploration. So what would it take to establish a permanent human presence on the moon? When could it happen, and are we up to that challenge? Let's pause for a few seconds and give me a like for this video. Thank you so much. Even before proposals were being made for lunar colonies, the idea of humanity living on the moon was explored extensively in fiction, with examples going back over a century. In addition, there was considerable speculation as late as the early 20th century that the moon may be already inhabited by indigenous life forms, much like what was believed about Mars. Between the 1940s and 1960s, science fiction author Robert A. Heinlein wrote extensively about the first voyages and eventual colonization of the moon. These included multiple short stories from the 1940s that describe what life would be like in settlements on Luna, the name commonly used by Heinlein to describe a colonized moon. In 1966, Heinlein released the Hugo Award-winning novel, The Moon is a Harsh Mistress, which tells the story of the descendants of a lunar penal colony fighting for independence from Earth. This story received wide acclaim for the way it combined political commentary with issues like space exploration, sustainability, and artificial intelligence. It was also in this work that Heinlein coined the term Tanstaffel, an acronym for There Ain't No Such Thing as a Free Lunch. In 1985, Heinlein released The Cat Who Walks Through Walls, where much of the book takes place on a free Luna after it won its fight for independence, and includes characters from some of his previous works. Lunar colonization was also explored in fiction by the late and great Arthur C. Clarke. This included the short story, Earthlight, 1955, where a settlement on the moon finds itself caught in the middle of a war between Earth and an alliance between Mars and Venus. This was followed by A Fall of Moondust, 1961, which features a lunar ship full of tourists sinking into a sea of moondust. With the beginning of the space race in the 1950s, a number of concepts and designs have been suggested by scientists, engineers, and architects. In 1954, Arthur C. Clarke proposed the creation of a lunar base, consisting of inflatable modules covered in lunar dust for insulation. Communications would be maintained with astronauts in the field using an inflatable radio mast. Over time, a larger permanent dome would be built that relied on an algae-based air purifier, a nuclear reactor for power, and electromagnetic cannons to launch cargo and fuel to vessels in space. Clarke would explore this proposal further with his 1955 short story, Earthlight. In 1959, the U.S. Army launched a study known as Project Horizon, a plan to establish a fort on the moon by 1967. The plan envisioned a first landing carried out by 2 soldier astronauts in 1965, followed by construction workers and cargo delivered using iterations of the Saturn I rocket shortly thereafter. In 1959, Johns Reinhardt, then director of the Mining Research Laboratory at the Colorado School of Mines, suggested a lunar structure that could float in a stationary ocean of dust. This was in response to the then popular theory that there were oceans of regolith that were up 1.5 kilometers, 1 mile, deep on the moon. This concept was outlined in Reinhardt's study, Basic Criteria for Moon Building, in the Journal of the British Interplanetary Society, where he described a floating base consisting of a half-cylinder with half-domes at both ends and a micrometeoroid shield placed above. In 1961, the same year that President Kennedy announced the Apollo program. The U.S. Air Force released a secret report based on the previous assessment of a lunar military base made by the U.S. Army. Known as the LUNEX project, the plan called for a crew lunar landing that would eventually lead to an underground Air Force base on the Moon by 1968. In 1962, John Dennick, the program manager for NASA's advanced programs, and Stanley Zahn, technical director of lunar basing studies in the Martin Company's Space Division, published a study titled Lunar Basing. Their concept called for a subsurface base located at the Sea of Tranquility, the future landing site of the Apollo 11 mission. Like Clark's proposal, this base would rely on nuclear reactors for power and an algae-based air filtration system. The base would be made up of 30 habitat modules divided between 7 living areas, 8 operations areas, and 15 logistics areas. The overall base would measure 1,300 square meters, 14,000 feet squared in size that could accommodate 21 crew members. During the 1960s, NASA produced multiple studies that advocated the creation of habitats inspired by the Apollo program's mission architecture, in particular, the Saturn V rocket and derivatives thereof. These plans envisioned space station modules being emplaced on the lunar surface and using existing designs and technology in order to cut costs and ensure reliability. In 1963, during the 13th proceedings of the Lunar and Planetary Exploration Colloquium, William Sims produced a study titled Architecture of the Lunar Base. His design called for a habitat to be built beneath the wall of an impact crater, with a landing field nearby for spacecraft. The habitat would be 3 stories high with the upper level providing a view of the surface through windows. These windows would also allow for light to enter the habitat and would be insulated with water tanks for radiation protection. Power was to be provided by nuclear reactors, while sections of the habitat would be dedicated to providing office spaces, workshops, labs, living areas, and a farm to produce as much of the crew's food as possible. Pause for a few seconds and support me with a subscribe. But perhaps the most influential design of the Apollo era was the 2-volume Lunar Base Synthesis Study, completed in 1971 by the aerospace firm North American Rockwell. The study produced a conceptual design for a series of lunar surface bases, LSB, that were derived from a related study for an orbiting lunar station. In more recent years, multiple space agencies have drafted proposals for building colonies on the Moon. In 2006, Japan announced plans for a moon base by 2030. Russia made a similar proposal in 2007, which would be built between 2027 to 32. In 2007, Jim Burke of the International Space University in France proposed creating a lunar Noah's Ark to ensure that human civilization would survive a cataclysmic event. In August of 2014, representatives from NASA met with industry leaders to discuss cost-effective ways of building a lunar base in the polar regions by 2022. In 2015, NASA outlined a concept for lunar settlement that would rely on robotic workers, known as transformers and heliostats, to create a lunar settlement around the Moon's southern polar region. In 2016, E.S. Afif Johan Crick Werner proposed the creation of an international village on the Moon as the successor of the International Space Station. The creation of this village would rely on the same interagency partnerships as the ISS, as well as partnerships between governments and private interests. It goes without saying that the creation of a lunar colony would be a massive commitment in terms of time, resources, and energy. While the development of reusable rockets and other measures are reducing the costs of individual launches, sending payloads to the Moon is still a very expensive venture, especially where multiple heavy launches would be called for. There's also the matter of the many natural hazards that come from living on a body like the Moon. These include extremes in temperature, where the sun-facing side experiences highs of 117 degrees Celsius, 242 degrees Fahrenheit, while the dark side experiences lows of -43 degrees Celsius, -46 degrees Fahrenheit. Most of the lunar surface is also exposed to impacts from meteoroids and micrometeoroids. The Moon also has an atmosphere that is tenuous. It is practically vacuum. This is part of the reason why the Moon goes through such extremes in temperature, and why the surface is pockmarked by impacts, i.e. there's no atmosphere for meteors to burn up in. It also means that any settlements will have to be airtight, pressurized, and insulated against the external environment. The lack of an atmosphere, as well as a magnetosphere, also means that the surface is exposed to far more radiation than what we are used to here on Earth. This includes solar radiation, which gets much worse during the solar event, and cosmic rays. Since the beginning of the space age, multiple proposals have been made for how and where a lunar colony could be built. The where is of particular importance, since any settlement will have to provide a degree of protection from the elements. As the saying goes, the three most important considerations in real estate are location, location, and location. For this reason, multiple proposals have been made over the years to construct lunar habitats in locations that would allow for natural protection and/or containment. Currently, the most popular of these is the South Pole Aitken Basin, a massive impact region around the Moon's southern polar region that is heavily cratered. One of the main draws of this region is the fact that it is permanently shadowed, which means that it experiences much more stable temperatures. In addition, multiple missions have confirmed the presence of water ice in the region, which could be harvested to make everything from hydrogen or hydrazine fuel and oxygen gas to drinking and irrigation water. Beyond that, any attempt to colonize the Moon will need to leverage technologies like additive manufacturing, aka 3D printing, robot workers, and telepresence. The base, or bases, will also need to be manufactured and supplied as much as possible using local resources, a method known as Insider Resource Utilization, ISRU. NASA and the ESA have been exploring the concept for many years, and both have produced their own methods for turning lunar regolith and other resources into usable materials. For example, since 2013, the ES has been working with the architectural design firm Foster Plus Partners to design their International Moon Village. Their proposed method for building this base consists of placing inflatable frameworks on the surface, which would then be covered with a form of concrete made from lunar regolith, magnesium oxide, and a binding salt. NASA has proposed a similar method which calls for robotic workers using sintered regolith to 3D print bases. This consists of melting regolith by bombarding it with microwaves, then printing it out as a molten ceramic. Other ideas involve building habitats into the ground and having an upper level that provides access to the surface and allows natural light in. There's even the proposal for building lunar settlements inside stable lava tubes, which would not only provide protection against the vacuum of space and impacts, but could be pressurized with greater ease. There's even the proposal for a solenoid moon base that would provide its own radiation shielding. This concept was presented by civil engineer Marco Perroni at the 2017 AI Space and Astronautics Forum and Exposition, and consists of transparent domes enclosed by a torus of high-voltage cables. This torus would provide active magnetic shielding against radiation and would allow for settlements to be built anywhere on the surface. The abundance of ice around the polar regions will provide settlers with a steady source of water for drinking, irrigation, and could even be processed to produce fuel and breathable oxygen. A strict recycling regimen will be needed to ensure that waste is kept to a minimum, and composting toilets will most likely be used instead of flush toilets. These composting toilets could be combined with lunar regolith to create growing soil, which could then be irrigated using locally harvested water. This would be essential, seeing as how the lunar colonists would need to grow much of their own food to reduce the number of shipments that would need to be sent from Earth on a regular basis. Lunar water could also be used as a source of power if the colonies are equipped with electrolysis batteries, where water molecules are split into hydrogen and oxygen, and the hydrogen is burned. Other power sources could include solar arrays, which could be built around the rims of craters and channel power to the settlements within them. Space-based solar power would also be able to provide abundant energy to settlements all over the lunar landscape. Nuclear reactors are another option, as are fusion tokamak reactors. This latter option is especially attractive given the fact that helium-3, a power source for fusion reactors, is more abundant on the lunar surface than on Earth. To be fair, establishing a colony on any of the celestial bodies in our solar system has some serious potential benefits. But having a colony on the nearest celestial body to Earth would be particularly beneficial. Not only would we be able to conduct research, extract resources, and reap the benefits of new technologies, having a base on the moon would facilitate missions and colonization efforts to other planets and moons. To put it simply, a colony on the moon could act as a stepping stone to Mars, Venus, the asteroid belt, and beyond. By having infrastructure on the surface of the moon and in orbit, which could refuel and repair spacecraft heading farther out into the solar system, we could shave billions off the costs of deep space missions. This is one of the reasons why NASA is planning on establishing a space station in orbit of the moon, the Lunar Orbital Platform Gateway, LOP-G, the Lunar Gateway, formerly known as the Deep Space Gateway. It is also one of the reasons why the ESA wants to build its moon village with international partners. China and Russia are also contemplating their own surface or orbital outposts for this precise reason. Lunar research would also be highly lucrative. By studying the effects of low gravity on the human body, astronauts will be better prepared to deal with the effects of long-duration space travel, missions to Mars, and other bodies where low G is a reality. These studies could also help pave the way towards the establishment of colonies on these bodies. The far side of the moon also presents serious opportunities for all kinds of astronomy. Since it faces away from Earth, the far side of the moon is free from radio interference, making it a prime location for radio telescopes. Since the moon has no atmosphere, optical telescope arrays, like the ESO's Very Large Telescope, VLT in Chile, would also be free of interference. And then you have interferometers, like LIGO and the Event Horizon Telescope, EHT, that would be able to search for gravitational waves and image black holes with greater efficacy. Geological studies could also be carried out that would reveal a great deal more about the moon and the formation of the Earth-Moon system. The abundance of resources on the moon, such as helium-3 and various precious and rare earth metals, could also allow for an export economy. This would be aided by the fact that the moon has a much lower escape velocity than Earth, 2.38 kilometers per second, 15 MPS, compared to 11.186 kilometers per second, 695 MPS. This is due to the moon having a fraction of Earth's gravity, 0.1654 grams, which means that launching payloads into space would be much cheaper. But of course, no lunar economy would be complete without lunar tourism. A colony on the surface, plus infrastructure in orbit, would make regular visits to the moon both cost-effective and even profitable. It's not hard to imagine that this could lead to the establishment of all kinds of leisure activities, ranging from resorts and casinos without Swedish licenses to museums and expeditions across the surface. With the right kind of commitment in terms of resources, money, and labor, not to mention some seriously adventurous souls, there could be such a thing as Selenians someday, or as Heinlein called them, loonies.